Hey, what is going on? It is Thursday, June 30th, 2022, and welcome to Chef the Algo Man. Yeah, that's me, and I'm here to come back, make a comeback, and start doing these coding videos again. It's been a while because I've been pretty busy, life stuff has happened, and yeah, you don't want to hear my whole life story, right? So you just want to get right to the coding. Yeah, so if you like my videos, like, subscribe, and comment in the comment section. I do appreciate any feedback, and yeah, I'm just addicted to making these coding videos for you. And you know, these Leetcode problems help me, they help you, I presume, and they help everybody, I think. Well, yeah, I guess. I don't know. Yeah, so let's get to it. The Leetcode problem of the day is the largest unique number. This is a Leetcode easy, and it's 1133. And yeah, so I just uploaded it. Yeah, so let's get to it. So the problem statement says, given an integer array nums, return the largest integer that occurs only once. If no integer occurs once, return 1. Okay, and you have your example 573959831, and the output is 8 because the largest number that occurs only once is 8, and we see that from this list here. The maximum number in the array is 9, but is repeated, so the number 8 occurs only once, so it's the answer. In this array 9988, the answer is -1 because there's no number that occurs one time, and thus there can't be a largest number that occurs one time. Okay, so pretty straightforward problem, I think. So how would we solve this? So let's just talk brute force way. The brute force way that we could solve this is by simply looking through all the numbers and going through the list, finding what number occurs more than once. We loop, we just check, we check every number multiple times in the list and see how many times that occurs, and then we check if that number has occurred once. If not, it occurs more than once. If not, then we go to the next number, and we have to keep track of which is largest. That's an n-squared algorithm because we're looping through the list twice. We don't even need to code that out. So let's get to the much faster algorithm. So this would involve a simple frequency map. So I'm going to use a frequency map. I could use a hash map, but just quickly, why am I using a frequency map? Because if you look at the range of the numbers, they're between 0 and 1000, and the total number of those numbers can be between 1 and 2000. So this is what we're interested in. Frequency maps, though, this looks like a lot, quote unquote. It's actually a lot faster than using a hash map. And so for those of you who've seen other videos of mine, if the amount is constrained, it's usually a lot faster than using a hash map, right? If this was billions and billions of numbers, maybe the hash map may be faster, but again, hash map has more computational overheads. But in principle, the time complexity is the same. Right, so we'll get to the time complexity in a bit. Actually, let's just talk about it now. If I was using a hash map, this time complexity would be, you could say it's O of the size of the map, right? In this case, the time complexity is constant, is O of 1. The space complexity is O of 1, right? The hash map, it essentially would be O of 1 there's two ways of looking at it, right? Because the largest number that can appear in this array is 1000, right? And so the hash map really needs to only store up to 1000 key values, right? So you can look at it that way. If you were looking at it as in an unbounded sense, it would be O of n, right? Because the number could be unbounded, and it's as large, the space is as large as the largest possible integer, could be infinity. But let's constrain it for now to the constraints of the problem and call it 1000. Why is it 1001 in this case? Because the largest number could be 1000. So if you start with 0, then you need 1001 spaces, right? Okay, so that's that. You need 1001 memory locations to store all the numbers. So we're gonna first iterate through our frequency map, right, my count map, and I'm going to increment the elements of the count map. And for now, we have all the elements of the count map, so we've gotten all the, we've gotten the total number of elements in this count map. And so in this example, for 5 it's equal to 1, for 7 equals 1, for 3 equals 2, for 4 equals 1, for 9 equals 2, for 8 equals 1, for 1 equals 1. Okay, so we've got that in there. And so now all we need to do, if count of the numbers equals 1 and nums I is greater than largest equals nums I. Okay, and there we go. So quickly explaining what I did here. And remember, we're starting with largest equals -1, because if this loop finds nothing that has a count of 1, right, it's not going to record anything. So it's going to default to -1. If it does find something whose frequency count, a number whose frequency count equals 1, then we set, and it's larger than the largest number, which starts at -1, then we're setting largest to nums, to that number, right? And that makes sense because in this case we look at the frequency count. We start with 1, so then that's the largest number that occurs once. 3 doesn't occur once. 5 occurs twice. 4 is the next largest number that occurs once. Then 5 is the next largest number that occurs once. Then 7 is the next largest number that occurs once. 8 is the next largest number that occurs once. So we record largest equals 8, and then 9 does not occur once, so we don't consider it. Let's run the code. Okay, there we go. And there we go. Okay? Pretty fast and pretty space efficient. Okay, well, that's my quick problem of the day. I could quickly show you how it looks like with a hash map, just, for kicks. So let's do this. And get or default. Put, see, there's a little more already text overhead here, code overhead. Then count that get nums I equals 1. All right, let's try this. See, that that worked. But look at that. Much slower, 9 milliseconds versus 1 millisecond, okay? And computationally, it's fast, right? But again, the overhead, the number of things the hash map has to do under the hood to allow this time complexity is greater than just using a frequency array. Because if you remember how a hash map works, a hash map uses hash chaining. So that means that's how the hash map deals with collisions. You can look that up, but I would say that that means that sometimes you don't have an O1 data structure here. You don't have a constant time data structure. You could have potentially a much larger data structure, because the way that keys are handled when you have collisions are that a large list is formed of keys or values for a particular key, and then you have to iterate through that list or that tree or whatever. So anyway, there you go. That's a quick solution. So we're done for today. Thanks for watching. Appreciate your time. Like, comment, subscribe, and I'll catch you tomorrow. See you.